So we're about to get into the next chapter, chapter 8. Oh my God. We talked a little, I put function notation up on the board a few days ago. Wonder how much you guys already know about functions. So, if I asked each of you how many ants do you have, right? Ants, however you want to say it. Right, if I asked each of you how many ants you had, and in fact, I would call you student 1, you student 2, and so forth. You guys with me? You guys with me? Yeah. Yes. Okay. So if you're not with me, I don't know what to do. Each one of you would have one answer, right? If you said, well, I have 2 or 3, depending on the day, what the hell what is that? What kind of court decision would have that happen? Or what kind of weird state would somebody be in? Phasing in and out. You guys with me? If I asked each person, what size shoe are you wearing right now on your left foot? You would all have one answer, right? You guys with me? If you're barefoot, you would say 0, right? Are you guys with me? But if I said, let me think. If I asked each one of you, tell me what are some of your favorite bands or something, then each of you could possibly have more than one answer, right? Maybe somebody like, I don't like any music. All right, that's 0, okay. But then somebody have several answers. So all of those are examples of relationships, right? Relations between, so this could be something that's not even mathematical. I could say, I could say, every person tell me the names of your cousins or something, right? So it's a relationship between you and names of cousins, right? You guys with me? So what we define as a function, so here's a relation between numbers. Let's make this more mathematical. So here's a relation between numbers. 1, 4, 2, 4, 7, 1, 7, 11, 6, -1. Okay. This is like student 1 telling me they have size 4 shoe. You with me? Doesn't have to be, obviously this would be like a -1, so it doesn't have to be something physical. This is just pure math now. So 1 relates to 4, 2 relates to 4, 7 relates to 1, so forth. This is not a function, because I want a function to be something more generally physically applicable. So it's, do you see how student number 7, if I said, how many ants do you have? And they said what? They said, I have 1 or 11, depending on what's going on. 10 of them sometimes check out, so I don't really count them as being my ant. And then they come back and, oh, yeah. No, that's bullshit, right? You guys? So I want a function. Also, what if I ask you, here's even something more physical. If I throw a ball in the air and I say, all right, 3 seconds later, how high off the ground is it? And you say 7 feet and 20 feet. The shit happened to that ball, right? Some portal thing going on. And even then, it's got to be through one or the other. Can't be in both. Unless it's like, I don't know. You with me? Unless somebody just chopped that sucker in half right when I let go of it. What? No. So to be physically applicable, I would need something that for every question I ask, for every input, there would be one output, right? So 3 seconds later, the ball should be in one place. I wish there's a way for things to be in 2 places. That would be really useful, but there just ain't, right? So a function is a special relation. What would I have to take out of here to make this a function? What's something I could have to, if I was allowed to delete one of these points? Yeah, one of these two. If I deleted this, that's a function. Why? Because every input has only one output. Now, these both go to 4, don't they? But that's fine. I could say 1 second later, the ball is at 4 feet. 2 seconds later, the ball is at 4 feet again. That's physically fine, right? Or I can say, how high off the floor is that book? 4 feet. Now how high? 4 feet. Leave me alone. So it could have repeated outputs, no problem. That could still make physical sense. But it just can't have different outputs for the same input. Okay, maybe. So, has anybody ever seen Highlander? Anybody know what Highlander is? The movie or the TV series? One person. Oh, you might be humoring me. I don't know. Yes? Yeah. What was the thing they would say right before they chopped off the guy's head? There can be... Yes, okay. It sucks. So you're the only one that gets this. So the definition of a function. The definition of a function. Here's the word definition, and then we're going to have a visual definition. For every input, normally that's what we consider X, right? That's our domain. Every input. There can be only one output. If that's true, then what I'm looking at is a function. Okay, I like it. So it's related to it making physical sense. If I have a function, it could actually model some physical thing. Maybe. So what would this look like then if I have a function and I graphed it? What would have to be true? So for every x, there can be only one y. So if I had a graph that looked like this, so this again would be like at 2 seconds, where's the ball? Well, it's 7 feet up in there, and it's 2 feet below the ground. All right, that is like an extra magic ball. That's like, what? That'd be a different game of baseball. And he hits it under the ground, and holy shit. Okay, no baseball. So like right here at 1 second, it's here and it's there. So for one input, for one value of x, there are 2 outputs. So visually, if I draw any vertical line, this might sound familiar. If I draw any vertical line, if it goes through more than once, it's not a function. All I need is just one vertical line. I could have several like this one, but all I need is one vertical line to go through more than once. That would mean this is not true. So we call that, and remarkably enough, being really creative people, the vertical line test, right? The VULT, the vertical line test. Venison, lettuce, tomato. No, the vertical line test. I like it. We stopped there for a second. So to be a function, every vertical line can go through only once, at most once, right? If there's any vertical line that goes through more than once, you violated this. Okay, I like it. And again, visually, if I throw a ball, it should look like this. Whee! And then hit the ground maybe or something, right? And sure enough, every vertical line I draw only goes through that bad boy once. Okay, I like it. So there are several ways I can ask a question about whether or not something is a function. I could give you a graph. If I gave you this one, you'd say, no, it fails the vertical line test. This one fails. This one passes the vertical line test. I like it. Or, so let me just give you several, and then I got a little handout here that we'll work on. So real quick, just make sure. This is not a function, but this is still a relationship. This is still a relation. It still relates values between x and y. It does. It's just not a function because it allows it to come back on itself. So is this a function, yes or no? Let's see. Is that a function? Does that represent a function?
Yes.
Why?
Because every single input has only one output.
Yeah, and the real shortcut is, are there any repeated x's? No. 0 only goes to 4. 7 only goes to 2. 5 also goes to 2, but only 2. That's what matters. Okay, so this is a function check. So obviously if I have 0, 4, 0, 3, who gives a shit? Is that a function? No, because 0 goes to more than one thing. At 0 seconds, where's the rocket? 400 feet up and 300, that's a problem. Something went wrong, right? It's not a good, that's not a function. What about, let me give it to you like this and just see what you guys think about this. Poor little 11.
Yeah.
The only way it would not be a function is if an input, something in the domain, these are the inputs, went to more than one thing in the outputs, the range. 1 only goes to 8. 2 only goes to 4. 3 only goes to 4. So how do I make this become not a function? I take 3 maybe and take it to, now that's not a function. This makes it not a function. So I'm using the same definition every time, but then you realize there's some shortcuts. If I see a repeated x, no. If I see arrows coming off from 2 arrows or more coming off from one dude, no. But each case, it's the same definition that I'm using. And then, of course, finally, I can just give you, what you got, Jeff? You know, is this a function? Yes, all day long. It doesn't come back on itself. There's no vertical line I can draw that would go through more than once. Obviously, any circle, so this is yes. Passes, the vertical line test. Any circle would automatically be not a function because there's a whole bunch of vertical lines that go through more than one. So that x would have more than one y, more than one output. No good. Poor little dude.
What's the vertical line?
Say again?
Just a vertical line on a graph, like x equals 3.
Yes. So that's why it relates to the definition. This represents an x value. Every vertical line represents an x value. So if it goes through more than once, that would represent that it has more than one output. 11. Kick ass. Okay. Where did I put those? Oh. Down there. Make sure I got everybody. Cool. Okay. So that's the definition function. And then, of course, you're going to have problems where they're like, is this a function or is this not a function? You've got to tell me why. Okay. The next level of this, I'm hoping most of you guys have seen before, but let's look at it. This is the part that I used earlier this semester, which means a few days ago. Function notation. How do you read this? F of x. I like it. I was worried somebody could say something really interesting. You weren't sure, but yeah, f of x. This is not f times x. And really, here's an example of a function that you all know how to say that relates to what you just said. How do you say this? Square root of 9. So what's the function here? The square root function. So this is the square root of 9. So this would be like if I said f of x equals the square root of x. This would be f of 9. So in general, what would the function do to something? Square root it. So what's it do to 9? Square roots it. That's what it does. So what would f of 9 be then in this case? 3. You can't divide by 9 because this is not times. This is what f at 9 is. Now notice something interesting. Can you tell me a point that this goes through if I were to graph it?
9, 3.
Yeah. For an input of 9, there's an output of 3. So that's another thing that's nice about function notation is I can see the input and the output all at once. So I can see the point that goes through. Kick ass. Another thing that function notation does for us is I'm able to define multiple functions easy. If I just kept using y, I'd have to be like, for the third one, what do you get when you put a 7 in? No, screw that shit. I want to be able to say, so let's say g of x is x minus 1 over x, and let's say h of x is, what you got, Jeff? Square root of x minus 2. Sure, a couple of square roots, why not? And I ask you, what is g of 2? So I very quickly told you two things: which function to use and what to put into it. In very little words, right? No words, really. Yeah.
It's 1/2, right?
Yeah. So you would put a 2 where?
Outside.
In the g, dude. So 2 minus 1 over 2. If g of x is x minus 1 over x, g of 2 is 2 minus 1 over 2. So it's really just a substitution problem. You should all agree with me that substitution, like a plus b squared, if a is 3 and b is 2, that's easy shit now, right? It should be really easy now. You're like, please give me some of that.
So
That's all these are.
So x means g? Is that what you're saying?
No. G means g, right? G of x is x minus 1 over x. So what's g of 2? Do I put a 2 here? No, I didn't say h of 2. Do I put a 2 there? No, I didn't say f of 2. I said g of 2. So what's h of 2? 0. Because where do I put 2 now? Into the h function. So now I know it's square root of 2 minus 2 square root of 0 is 0. So the letter tells me which function to use. And then the number inside tells me what to put into it. If you think about it, it's really nice. The 2 is in the g. It kind of tells you, put the 2 into the g. Okay, let me do that. Put the 2 into the g. Okay, let me stop there for a second. Yeah.
Each of those letters are essentially representing an input value on like a graph. Is that what that is? No.
The letters identify which function I'm using.
Okay.
What's a point on graph G? If I were to graph this function, what's a point that it goes through? 2, comma, what half? What's the point that H goes through? 2, comma, 0. The letter I use, why did I use an H for this? Because I had already used G and F. I could have called this one G and this one F and this one H. It doesn't matter with anything. It's just a way to distinguish between them. Yes, sir?
You don't have to use F, G, and H. You can
No,
use
exactly.
A, B, and C.
I
Right?
love, it's like I planted you out there. So if I had a profit function, I could use P for a profit function. If I had a cost function, I could use C. If I had a number of hot dogs sold, I could use H. If I had, whatever. You can use a letter that relates to the physical situation. Cool. Number of tickets sold, T of X. It's amazing. Yes?
And the answer will be y, right? We're just trying to find
Yeah,
y.
good. So this symbol, this is taking the place of y. It means y, it's just another way to write the output. I like it. Okay. Let's see. What else we got? Oh. So I keep saying this. Let's look at something specific here. Let's make something you guys should be used to by now. Look at h of x. Let me ask you this. What's the smallest value of x? In fact, we pretty much already used it. That h can handle as an input. No. If you put a 0 in, you get square root of -2. So what you're really thinking is, if the inside is 0, and what makes the inside 0?
2.
That's the smallest number I could use. Because anything below that, I start getting weird, complex numbers. So if I put a 2 in, you get 0 out like we just did a minute ago, right? That's the one. Well, what if I put a 3 in? What do I get? You get the square root of 3 minus 2, square root of 1, it's 1.
1.
I'm not going to put a 4 in there, because I get the square root of 2, which is kind of gross. Or 5. Next number I want to use is 6, because then the square root of 6 minus 2 is the square root of 4, which is 2. Now, can I graph those points? I want to graph this function. I want to see what it looks like. Maybe you've never seen the graph of a square root function before. It don't matter. How do I find the graph of something I don't know? I make a list of values. All right. Start making an XY table. But now it's an X, h of x. So this is what y is, right? That's the output. So 2, 0. So 2, 0, 3, 1, and 6, 2. So this thing looks like, so that's what a square root, if you notice, a square root is like the opposite function of what? Square rooting is the opposite of, specifically, squared, right? And what's a square look like if you graph it? You should know this, maybe. Do you know this? What's a squared function look like if you graph it? Looks like a what letter? A U. And this is the opposite, but look how it looks like this. It looks like a U that fell over, and this part fell off, right? There's this part down here. There's this part that's missing. And why is that? Because the square root can't be negative. So that half is just not there. Do you have to know everything I just said to be able to? No, of course you don't. But it's interesting. It is the opposite of a square root, and it looks, the opposite of a square, and it looks like the sucker fell over and it can't have a negative. It looks like half of a parabola fell over, had a rough night. So, now watch. Why did I put a point here? This is kind of a silly question, but why did I put a point there? Well, no. So, what about this point? Why is there a point right there? What does that mean about this point? Why is there a point there?
So if you plug that in as an input, that's what you get?
Yeah, because that point works in this function, right? The h function, that's what we're using. That point works in that function, right? So, that means if I give you this backwards, if I gave you something backwards and you're like, that's all it feels like you do, man. If I gave you, here's the function. This is a new problem, right? It's not the same as that. I'm just going to give you the graph. That's all I'm going to do. And then I'm going to ask you questions about the function. That seems really mean. I'm not going to tell you what the function is. Just don't feel like it. Let's say we go here, 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 and there. Say, woo-ha, woo-ha. Okay, a couple things I want to ask you. So I didn't tell you what the function is. Cool? It looks like it could be some kind of a... We'll learn later that squares look like this. Cubes look like this. So it looks like it could possibly be some kind of weird-ass negative cube, and you don't have to know any of that shit. But what must f of 0 equal? I don't know what the function is, so how the hell am I going to answer that question? Because I gave you the graph. That's even better. What must f of 0 be?
You look at the graph and see why it's one.
Exactly. So it must be 3. So people look at that and they say, that's not fair. You didn't tell me what f was. I'm like, I gave you something better. I gave you the answers. You don't have to do any shit at all. You just got to see where the point went. Why did we put a point there? Because that was the answer. Right? So somebody went, I didn't know what this was, but knew what this was. They know when I put a 3 in, I get a 1 out because that's where the point is. So what is it? F of 0? 3. What is f of negative 3? 0. That's where the point is. That's the output. For an input of negative 3, what's the output? 0. Because the point goes to the point negative 3, 0. What that question is really asking you is, if the x piece is 0, what's the y piece? 3. Because it goes to the point 0, 3. F of negative 3 is 0, and I could keep going. All right, second thing I want to ask you. What is the domain and the range of this function? So what's the domain of this function? What does domain relate to?
The x's.
The x's. It's all the x's I'm allowed to use.
Negative 3 to 3.
Beautiful, right? So I always tell people it relates to x. So I have a little dude walking on the x-axis. There's a little dude walking on the x-axis. What's the first time he sees the graph looking up and down at negative 3? And then he sees it all the way. It keeps having outputs all the way until he gets to 3. So what x values have outputs? Negative 3. What are you doing over there? Negative 3 to 3. Become 3. So what do you think you do about the range?
Do what?
Look at the y-axis. What's the lowest output that happens? Well, it's a little bit hard, but let me make it, I try to make it a little bit. Definitive. Yeah, -2. That's the lowest output I see. And then I see outputs everywhere until I get up to 3. That's the last output I see. So when I give you a graph, good Lord, don't make the domain and range a hard thing at all. Just look at the x for the domains where the x values actually have outputs. And then what, on the y-axis, say what outputs actually happen. So, any questions on that weirdness? All right. I'm about to give you something. On one side is something I want you to work on right now, and that's the function worksheet. It says section 8.1. The other side is the practice test. I'm just trying to save paper. So work on this side right now, the function worksheet side. Represent that row.